Subtraction models and algorithms depend on a couple of things. What does subtraction mean? So we have to make sure we have a concrete foundation on that. And then what do our numbers mean? We need a concrete model for that. And usually we use some kind of toy to demonstrate what a number means, like for counting. And often because of our number system, we use base 10 blocks. So I have some of my sketches of base 10 blocks, and then we'll play with the Math Learning Center app. So what does subtraction mean? I think most people that are educated would say, well, it means take away, right? So that's the most common way, but it's not always what subtraction means. So one idea for subtraction is the idea of takeaway. So for example, when we write a subtraction problem like 6 minus 2, 6 subtract 2, we think 6 take away 2, and that I have 1, 2, 3, 4, 5, 6 things, right? So this is what I start with. And then from there, I take away physically 2. So maybe I would grab that one and that one. And then we can see that leaves 4. But there's other ways that we can think about what takeaway means. The idea of 6 take away 2, and the other is a comparison. So how does 6 compare to 2? So in that case, we're asking a slightly different question, but it's still a subtraction. So with this, I might draw 6 things and then compare that to 2 things. And in that comparison, I can see that there's a difference here. That 6 is 4 more than 2. There's no takeaway here, right? Maybe 2 friends get together, 2 kids. One kid has $6, the other kid has $2. It's clear to them that one kid has more than the other. How much more do they have? Well, they have $4 more. So one kid isn't taking anything from the other kid, right? That would lead to some serious confrontation. We're not taking, we're just comparing. And so subtraction does a couple of things. In reality, it's a comparison between 2 things, finding what we call the difference. Or it's actually taking one set of things away from another set of things, which is another physical way subtraction happens in our reality. So we have these 2 distinct versions of subtraction, where I start with 6 and just take 2, or I compare 6 to 2 and see how they're different, right? So they're different by 4 there. So those are the 2 big ideas of what subtraction physically means. These are called models for subtraction. So a model is some physical reality about the operation that we're working on. Whoa, my pen is freaking out there. Physical representation. And I think these are the 2 most important ones. We have the takeaway model for subtraction, and we have the comparison model. There are other models in subtraction too, physical ways to think about subtraction. I think they're more like comparison, but some people think they're different. So I just want to, these are kind of like sub models maybe. So we've got a number line. It's a physical way to represent stuff. And another way is to compare to addition, and we can call that the missing addend. I think I got one extra D there. So the number line model is pretty straightforward. Normally on a number line, a number is a distance to the right. And what subtraction does is it tells us to turn one of the numbers around. And if we compare that to the number line with addition, where we just tack them together, the subtraction turns around and just leads to a slightly different result. So just a reminder about number line addition. Get a number line. And if I wanted to show something like 6 plus 2 on the number line, I would need to have some numbers on there. So let's set that up. And the number line's nice because this is often on kids' desks in a classroom. You'll have a ruler or a number line on the desk or on their notebook. Just going to make a copy of that to compare to subtraction. So with the addition version, I would show what 6 looks like. So I'll draw that up here. So there's my distance of 6, and then I combine with that a distance of 2. So we just do a straight combination, and we can see that 6 plus 2 plus gives us 8. 6 minus 2 is going to be a little bit different in that the subtraction, we turn the 2 around. So starting with my 6, for the 2, I just pick up where the 6 left off, but I go backwards, right? I turn around, and this shows me that 6 minus 2 is 4. And physically, right, that is different than, say, this comparison here or the takeaway there. I have a different picture. It's a different physical reality. But in a sense, it really is a comparison. And there's a couple of different ways we can draw that. This is the most common one right here for drawing it on the number line. The missing addend basically asks us to think about the subtraction in terms of addition. So 6 minus 2 equals what? We just kind of rephrase it backwards with addition. So rewrite backwards, because addition and subtraction are kind of backwards of each other. So starting here, I would say what plus 2 equals 6. And then we could count up 2, 3, 4, 5, 6. Okay, it looks like 4 plus 2 equals 6. So 4 is my missing addend, right? The missing piece of addition that leads to the subtraction. So that's a slightly different physical way of thinking about subtraction by redoing it as an addition problem. So we've got models. Models are our physical ways of thinking about what something means. In this case, subtraction. Takeaway, physical situations where we lose stuff, we give away maybe, like when I have to pay for something. Comparison, when we're comparing two different sets, but there's no taking or giving. We're just saying, hey, how are these two different? Number line, like a comparison, but drawn on a number line with little arrows or jumping around on the number line. And the missing addend where we rewrite it as addition. So those are the models. Now, models are great. They help us think about what does subtraction means. Why do we get an answer like 4 when we do 6 minus 2? Why isn't it something else? Why isn't the answer 3? Okay, well, because subtraction means take away or compare. That's why. So without that definition, we don't have an answer. Now, that's all great. Good to get started with subtraction means we have a physical way to do it, but problem comes up when we start having to work with bigger numbers. Like when I want to think about, say, 27 take away 13. I don't really want to draw 27 things and 13 things. We really don't want to have kids do that too, but we can model it with base 10 blocks. Once we get to bigger numbers like that, or maybe 328, take away 175, again, drawing 328 things, drawing these on a number line, right? Those are all tedious tasks. For bigger numbers like this, we need algorithms. And an algorithm is a process to just get the job done, knowing what subtraction means. And an algorithm is just a process. What's the procedure to do this? I don't want to draw it. I just want to do a little calculation. How do I do that calculation? So we have a standard way of doing this. And the question is, well, why do we do it that way? Why does that work? So I'm going to write down what I believe we would call the standard algorithm, what you and I grew up learning, but different countries do different things. The standard algorithm is also called the renaming algorithm. And so, for example, the 27 minus 13, we just think about place value. 7 ones take away 3 ones is 4 ones. 2 tens minus 1 10 is 1 10. So we think 27 take away 13 is 14, or 27 compared to 13 is they're different by 14. Now that one was pretty straightforward. It was just two simple 1-digit subtractions combined together based on place value. 328 minus 175, that's a little more interesting. And that's where we'll see about this idea of renaming. 328 take away 175 starts off pretty straightforward. 8 ones take away 5 ones, no problem, that's 3. But the 20 take away 70, the 2 tens take away 7 tens, we can't take more than what we have. So this is a problem, and that's where this renaming comes in right here. What we do is we rename this number. Instead of 300s and 2 tens here, we say, let's knock that down to 200s and make this 12 tens. We played around with that earlier in section 3.1, that there's different ways to group stuff together. So 328 is the same as 200, 12 tens, and 8. So we've just renamed this number. So now we can say, let's try 12 minus 7. Oh, that I can do. All right, 12 minus 7 is 5. And then 200 minus 100 is 100. So that's the idea of the renaming algorithm. I call it also the standard algorithm because that's the way it's mostly taught in the US. But there are other ways to do it. So I'm just going to demonstrate another way, and we'll talk about why it works. And again, algorithm is just some procedure people follow. They just follow those rules and out pops an answer. So here's a commonly taught one. Let's take our 328 minus 175. And it starts off the same way, 8 take away 5, that's no problem, that's 3. Now here with the 2 minus 7 or the 20 minus 70, that is a problem. And so I would like that to be bigger than 2, so I'm going to just make that a 12. Because then I can do 12 minus 7 or 120 minus 70. Now, what I've done right here is I've added 100 to the top number by putting that 10 there. In this algorithm over here, to compensate adding 100, we took away from 100 here to balance it out. What I'm going to do instead down here is I'm going to add that 100 here, and I'm going to add 100, but I'm going to do it down there. So that becomes 200. So that 12 is 12 tens, right? Which is 10 of those 12 tens is 100. 10 tens is 100. And here I just put another 100. 12 take away 7, that's 5 like before. 3 take away 2, or 300 take away 200, that is still 1. I get the same answer. This algorithm right here is called equal additions. And we'll play with it some more. So this is an algorithm that's commonly taught some places in the US, some places in South America and Europe. Another alternative algorithm sometimes called Hindu algorithm, or left to right. So like in other countries, some languages, they read in a different direction. We read left to right, but and do some of our math right to left. In other countries, they read right to left and they do some of their math left to right. Can that possibly work? Let's try. 328 minus 175. So we just start on this side here. 300 minus 100 is 200. We just put the 2 down there in the right place value, right? In that column, that is 2 hundredths. Now, I want to take 20 minus 70, but I can't, so I borrow from below. 12 minus 7, or 120 minus 70 is 50. That 5 definitely belongs in that column there. It's 5 tenths, no problem. And then 8 minus 5, that's no problem either. That's 3. And so I can see my answer here is 153. So that's the left to right algorithm. With the Hindu left to right algorithm, important thing here is we end up borrowing from below. And there's a lot of different ways people do subtraction around the world. These are just a few of them. The renaming algorithm, common in the US, the equal additions algorithm, which is common in some places in the US. And then we have the Hindu left to right algorithm. So right, we have here so far is we have an overview of subtraction models and algorithms. And now we just need to play with them some more.